Welcome to Computopedia, the channel where we learn about computer science. In this video, we're going to learn about normalization, and this is the introduction to normalization in databases. This is the final video of the series Database Laboratory Activities here in UGM, Universitas Gadjah Mada. Still with me, Zikri Radian Fudori. Now, let's get into it. So what is a normalization? The process of normalization is that it's a data analysis technique to design a better database system. It allows the database designer to understand the current data structure in an organization. Furthermore, it aids any further changes and enhancement to the system. Therefore, it will build a better database system. Normalization is a technique for producing relational schema with the following properties, which is no information redundancy and no update anomalies. No anomalies. At the end of the normalization, we will have a set of entities that does not have redundancy or duplication of data and avoids any anomalies. So that's the end of the normalization. Before we go further, we must know what are the anomalies. And what is the anomalies? Anomalies are inconvenient or error-prone situation arising when we process tables. This is not like a pure bug, but maybe half bug, because sometimes it's just run fine, but the logic behind of the database will be error, will be wrong. There are three types of anomalies that we are going to discuss in this video. The first one is update anomalies, the second one are the delete anomalies, and the third one are insert anomalies. We go to the update anomalies first. An update anomaly exists when one or more instances of duplicated data is updated, but not all. So I think we must underline the but not all. For example, we have the example table over here. We consider John's moving address. So he moved house. You need to update all instances of John's address. So we see here the student name Jones and Jones over here. We have two. If we just update one, then there will be some update anomaly. For example, John address here in Edinburgh, and then he moved to London. If we just update only one, then there will be the update anomalies. But if we update all of the address which have the name Jones, then that's not an update anomaly. But these kind of things are quite burdensome, so it's quite hard. Imagine if the student name Jones are like 100 or maybe 1,000, then the address, we need to change the address 1,000 times. Now, the second one is the delete anomaly. A delete anomaly exists when certain attributes are lost because of the deletion of other attributes. Let's see the example. Consider what happens if student S30, so he's here, student S30, which is Richard, is the last student to leave the course. All information about the course is lost. So we have the course name over here. If we imagine that the Richards are no longer attending the course 9201, or this one, so we want to delete the S30. Like, for example, these students are already graduated, so we want to delete them from the database, but here the S30 or Richards are the last who attend the math course. So if this was deleted and then the course number 9322, which is math, are going to be gone as well. That's the delete anomaly. So a simple way to explain is that we delete something that was supposed not to be deleted. That's the delete anomaly. Lastly, about the insert anomalies. So the insert anomalies occurs when certain attributes cannot be inserted into the database without the presence of other attributes. For example, this is the converse of delete anomaly. So this is the other side of delete anomaly. We can add a new course unless we have at least one student enrolled on the new course, because as we see before, if the math are gone, and then we cannot add new math students, and that's a problem. That's the insert anomaly. So to avoid that anomalies, we do normalization. And how do we do that? So we have the stages. Normalization itself is a process involves applying a series of tests on a relation to determine whether it satisfies or violates the requirements of a given normal form. So we tried an error. We tried something. If it's fine, then that's fine. If it's violates, and then we must do something. When a test fails, these rules. When a test fails, the relation is decomposed. So we split it into simpler relations that individually met the normalization test. The higher the normal form, the less vulnerable to update anomalies and the relations become. We have three normal forms that we're going to see the example in this video, which is 1NF, 2NF, and 3NF, were initially proposed by Cott. All of these normal forms are based on functional dependencies. If you want to learn more about functional dependencies, so please comment below. I will make a separate video for that if you want to. Among the attributes of relation. So here are the steps. Normalization follows a stage process that obeys a set of rules. So on the step are, we select the data source and then we convert it into an unnormalized table, or the UNF, just like the example before. Those are UNF, just a table without any normalization. And then the step 2 is to transform that UNF into the first normal form. The third step are from the one normal form, the first normal form, into the second normal form. And then lastly, the step 4 are from 2NF to 3NF. Like, the steps are simple enough, but it's not that simple. So what is beyond 3NF? Is there anything more about the 3NF? Yes. There's still a probability of anomalies even though it's in third normal form. In this case, we may perform further transformation. We also have the Boyce-Codd normal form, or BCNF. And we also have the 4NF and even to the 5NF, or the fifth normal form. Let's see the example. But in this video, we're just going to see until the 3NF. If you want to learn more about the normalization, it's gonna take a while, so please do Google and do your self-paced learning. Now for the example, we will demonstrate the process of normalization, which is 2-3NF, by using an example. Normalization is a bottom-up technique for database design. So we create the tables from bottom, that means from the UNF to a higher normal form. Normally based on an existing system, which may be a paper-based, or any system are not strictly limited to a computer system. It can be just a normal system, a human interaction with human to human, or even a paper-based system. Then we start by analyzing the documentation, reports, screen layout from that system. Just like on this example. We will begin the project management report. So this project describes the work upon by employees, and this report is to be normalized. So these are the data source that we are going to build. Let's see here, we have the project management report, we have the project code, project title, the project manager, the project budget, the employee number, name, department number, department name, hourly rate, and then the total staff, and the average hourly rate. Because it says here it's a calculated fields, and we don't really need to store this on the database. We can just like aggregate using the SQL syntax. The first step is that we select the data source, which is this one, the project management report, and then convert it into a unnormalized table, or UNF. The process is as follows. We create column headings for the table for each data item on the report. So like the project code, project title, project manager, project budget, and so on. However, without the calculated fields. So the total staff and the average hourly rates are calculated fields, so we don't count them because they can be derived, as I said before. And we can also enter a sample data into the table. The next step is to identify the key for the table and underline it. So from that column, we must choose one column as the key, as the primary key. Of course, we have to follow the rules of the primary key itself. It should be unique and so on. Then we remove duplicate data. In this example, for the chosen key, project code, the values of project code, project title, project manager, project budget are duplicated if there are 2 or more employees working on the same project. So yeah, if there is more the employee, we can duplicate the employee itself. Project code has chosen for the key, and duplicate data associated with its project code is removed. So we must not confuse the duplicate data with repeating attributes, which is described in the next step. So here are the UNF. We can see here the project codes are duplicated, but it's a unnecessary duplicate. That's totally fine. Now we go to the step 2. In this step 2, we transform the table, the UNF, to the 1NF. Any repeating attributes are put to a new table, and the repeating attributes in the data field within the UNF relation that may occur with multiple values for a single value of the key. The process is as follows. We need to identify the repeating attributes, which one is the one that's repeating. We remove these repeating attributes to a new table together with a copy of the key from the UNF table. So we copy the key. Then we assign a key to a new table and underline it. This is like just the usual agenda. There are some notes. So after removing the duplicate data, the repeating attributes are easily identified. In the previous table, we see the table employee number, employee name, department number, department name, and hourly rates attributes are repeating. There is a potential for more than one occurrence of these attributes for each project code. And these are the repeating attributes and have been to a new table together with a copy of the original key, which is the project code. A key of project code and employee number has been defined for this new table. And this combination is unique for each row in the table. So we see here, we put it into two tables. We have the project code and the project title and the project manager, because in every project code, in one project code, will only be one project title, and there will be only one project manager, and there will be only one project budget. So therefore, they are separated from the rest of the table. Therefore, we are reducing any duplicate data. And the ones that in the main table over here are just the primary key of the previous table. Right, now in this one, we create the primary key if the project code and employee number. Now move on the third step. We transform the 1NF data to the second normal form. We remove any key attributes which have partial dependency that only depend on part of the table key to a new table. So what has to be determined is that is field A dependent upon field B or vice versa. And this means that given a value A, do we then have only one possible value for B and vice versa? If the answer is yes, A and B should be put in a new relation with A becoming the primary key. A should be left in the original relation and marked as a foreign key, left in the original table. And we must ignore tables with a simple key, which is only one key, and with no non-key attributes. So without a key, there's also cannot. We'll always go straight to the 2NF. The process is follow. We take each non-key attribute in turn and ask the question, is this attribute dependent on one part of the key? If yes, we remove the attribute to a new table with a copy of the part of the key it is dependent upon. The key it is dependent upon becomes the key in the new table. Underline the key in this new table. If no, check against other part of the key and repeat above process. If still no, then not dependent on either part of the key, keep attribute in the current table. These are the steps. There is some notes. So the first table went straight to 2NF as it has a simple key, which is the project code, and then the employee name and department number and so on are dependent upon employee number only. Therefore, they were moved to a new table with the employee no being the key, employee number. However, the hourly rate is still depend upon the both project code and the employee number. As an employee, we may have different hourly rate depending upon which project they are working on. Therefore, it remains on the original table. So we see here we have three tables. This is the one. The first one, we didn't change anything because they only have one primary key. But on the second table, we have two primary key, which is the project code and then the employee's number. Because of the employee's number having a few dependence value, so here they are having their own table, and then this one are still here. Even though there's still two keys over here, the project code and then the employee number. Now, the last step in this video about normalization is that the step 4, data in the second normal form or 2NF will be changed into 3NF. We need to remove to a new table any non-key attributes that are more dependent on other non-key attributes than the table key. So we need to check the connection between the non-key attributes. So what has to be determined is field A dependent upon field B or vice versa? And this means given a value A, do we then only have one possible value for B and vice versa? If the answer is yes, then A and B should be put into a new relation and A becoming the primary key. A should be left in the original relation marked as foreign key. We also ignore tables with 0 or only 1 non-key attributes. These are straight to 3NF without any conversion. The process is as follows. If a non-key attribute is more dependent on another non-key attribute than the table key, then move the dependent attribute together with a copy of the non-key attribute upon which it is dependent to a new table. Make the non-key attribute upon which it is dependent the key in the new table. Underline this key, so the primary key, and leave the non-key attribute upon which it is dependent in the original table and mark it as a foreign key. So the foreign key are still the key, the primary key of the other table. The notes for this step is that the project team table went straight from 2NF to 3NF as it only has one key attribute. So I think there will be no change. Department name is more dependent upon department number than employee number, and therefore was moved to a new table. Oh, there's some change. Department number is the key in this new table and foreign key in the employee table. So we have 4 tables right now. We have the project code, project title, project manager, and project budget. That's still the same. The project code and employee number with the hourly rate, that's also still the same. Now we see that the employee number, employee name, department number, here are the new foreign key, and here are the new table, which is the department number and then department name. So here are the primary key of this department table. So to summarize, this is the complete process, which is having start off with an UNF until we finish with 4 normalized tables in 3NF. So bottom up from UNF to 3NF. You will notice that duplication has been removed apart from the keys to establish the links between tables, keys and foreign keys. And the process may look complicated, but I think it may be complicated until we follow the rules completely. So just follow the rules, and if you want to learn about the rules, about how do we do normalization, just please comment below and I will make another video just to explore more about the normalization itself. And please do not miss out any steps, then you should arrive at the correct solution. If you omit any rule, there is a high probability that you will end up with too few tables or incorrect keys. So if you omit a rule or if you run the rule wrongly, there may be some consequences, a higher probability of too few tables or incorrect keys. And that is I think the introduction of the normalization. So once again, if you want to learn more about normalization, please do chat, comment, or you can find your own source online about the normalization itself. Hopefully this will help you as an introduction to the normalization. And this is the end of the series of database laboratory activities from me in Universitas Gadjah Mada. So thank you once again. I'm sorry if I say something wrong. Hopefully I can correct that in the futures, and see you on the next video. Bye bye.